Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on January 5th, 2026, about 6 days ago. It introduces Talk2Move, the first reinforcement learning framework that successfully handles precise object-level geometric transformations, like rotating or resizing specific items in a scene, solely through text instructions. The paper is titled Talk2Move, Reinforcement Learning for Text-Instructed Object-Level Geometric Transformation in Scenes. And as we'll see later, the method achieves significantly better accuracy and scene consistency compared to current state-of-the-art models. So, Figure 1 shows the model in action compared to existing methods. On the left, we have an input image with instructions to move a mug, rotate a character, or scale them down. The grid on the right displays the outcomes, where red boxes highlight how current top models like GPT Image 1 often fail to execute these precise geometric changes. In contrast, the green boxes in the far right column demonstrate how Talk2Move accurately follows the spatial commands while preserving the scene's background. Well, while the previous figure showed the results, Figure 2 breaks down the complete system pipeline. On the far left, the data curation component creates synthetic training pairs by using video generation and editing models to simulate object movements. The main section, the Group Relative Policy Optimization Training Pipeline, then uses this data for a cold start before switching to reinforcement learning. Here, the model generates diverse editing trajectories, which you can see branching out in the center. Finally, the spatially grounded rewards block on the right evaluates these edits using specialized tools for rotation and scaling, feeding that signal back to optimize the policy. Alright, Figure 2 outlined the pipeline, but Figure 3 details how the model accelerates training. The top row, labeled A, shows the standard approach, which processes every single step from start to finish. The middle row, B, improves this with a sliding window, shown in yellow, which limits optimization but still samples every step. In contrast, the bottom row introduces active step sampling. Here, the model identifies only the critical steps in red and takes a shortcut to the end, significantly reducing total computation. So, having seen the training efficiency in the previous figure, Table 1 now quantifies the performance on the synthetic benchmark. It compares the method against baselines like GPT Image 1 and QN Image Edit across 3 distinct tasks: translation, rotation, and resizing. The results in the bottom row show that Talk2Move dominates across the board. In the translation columns, it achieves over 76% accuracy, which is a massive jump over the others. Furthermore, the human win rate remains consistently superior for rotation and resizing, confirming that the model produces edits that actual users prefer. Well, while the previous table focused on synthetic data, Table 2 shifts the evaluation to real-world scenarios using the OpenImages v6 dataset. The columns here track performance across translation, rotation, and resizing tasks. Looking at the bottom row, Talk2Move maintains a clear lead in translation with nearly 54% accuracy, surpassing the next best model, QN Image Edit. It also secures the highest accuracy in rotation at roughly 31%, proving that the method effectively handles complex, real photographic scenes. Okay, while the previous table verified the results, Table 4 investigates the efficiency gains from the active step sampling strategy. It compares the standard full sampling against the proposed method. The total time column reveals that the new approach cuts computation roughly in half, dropping from 172 seconds to about 87. Crucially, this speed doesn't come at a cost. The accuracy on the far right actually improves to nearly 77%, confirming that focusing on key transformation stages benefits both speed and performance. So, earlier tables established the numbers. Now, Figure 5 provides the visual proof. This grid compares Talk2Move, shown in the far right column, against leading baselines like Flux Context and GPT Image 1 across translation, rotation, and resizing tasks. For instance, in the first row, the instruction asks to move a chair to the left. While competing models often distort the object or ignore the spatial command entirely, Talk2Move cleanly executes the shift. Similarly, in the bottom rows for resizing, it accurately scales the tree while preserving the background, confirming the model's superior geometric control. Wrapping up, 2 takeaways stand out. Talk2Move proves that reinforcement learning can master precise geometric editing, solving tasks like rotation and resizing where standard models struggle. Also, by using active step sampling to skip redundant computations, it achieves this control with impressive efficiency. This method offers a scalable path toward truly controllable visual generation. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.